Chatbots function as intelligent text generators. They respond to inputs based on patterns learned during training, but they are reactive by design. They sit idle, waiting in isolation until a human user prompts them. For industries like healthcare, finance, and defense, generating text is only a starting point. These sectors require the execution of multi-step actions. A hospital network must audit patient records and schedule follow-ups. A financial institution must analyze live transaction data and freeze compromised accounts. Addressing these requirements requires a shift from reactive models to proactive AI agents. An agent perceives its environment, reasons through obstacles, and acts to achieve a specific goal without requiring constant human intervention. A standard model might alert a technician to a server anomaly. An agentic system goes further. It investigates the root cause, maps the dependencies, and deploys the necessary software patch to resolve the issue. To handle these industrial challenges, artificial intelligence requires a functional anatomy that allows it to interact directly with both the physical and digital world. This anatomy begins with senses. Through late fusion multimodal processing, an agent ingests diverse data types simultaneously. It analyzes text documents, medical images, and live numerical telemetry, processing them within a single, unified analytical space. The brain of the system is the large language model. The LLM uses chain-of-thought reasoning to break massive, complex goals into smaller, logical steps, mirroring how a human processes a difficult problem. However, relying strictly on the LLM's internal weights carries a risk. Models can confidently hallucinate answers when they lack factual grounding in your specific, localized business data. This RAG pipeline serves as the agent's factual memory. Context injected into the Anven inference engine comes from a secure vector database. By converting queries into vector embeddings, the system searches private knowledge bases for exact facts before the agent takes action. Pairing the reasoning engine of an LLM with the factual memory of RAG creates a cognitive architecture that grounds every decision in absolute truth. LangChain application orchestration acts as the agent's hands. In the agentic layer, the model selects external tools and APIs to query databases. On the left, the memory module drives the autonomous loop, persisting state to remember outcomes and iterate logical steps. Granting an autonomous agent the ability to act on sensitive data, like patient records or financial ledgers, introduces a security bottleneck. In these environments, any data that leaves the internal network to a public cloud represents a potential breach of regulatory mandates. This diagram displays the LangChain orchestration ecosystem secured by Treecapital AI's Anven model. Anven is engineered as a sovereign AI layer, designed specifically to operate within the strict boundaries required by highly regulated industries. Anven operates entirely within a company's private, air-gapped cloud or directly on edge devices. This deployment model guarantees that the reasoning loop stays inside the network, ensuring zero exfiltration of proprietary logic or sensitive data. The power of an agent's anatomy is tethered to the security of its environment. For a regulated enterprise, these reasoning and action layers only become operational assets when they are contained within a private, sovereign architecture. Enterprise AI is evolving toward a hierarchical digital labor workforce. A single high-level planner node decomposes a strategic goal and distributes the individual pathways to multiple specialized worker nodes beneath it. These specialized agents collaborate to execute cross-functional workflows. A coding agent, a database lookup agent, and an evaluation agent work in parallel, completely walled off from the public internet. This architecture changes the role of the human worker. Humans move away from executing individual tasks and instead focus on setting high-level strategic goals and defining the operational constraints. Through a human-in-the-loop architecture, supervisors review an agent's proposed action plan. The human evaluates the reasoning chain and checks for compliance risks before providing final authorization for execution. Human feedback refines future reasoning. By correcting a plan before it is executed, a supervisor provides the guidance the model needs to adjust its internal logic, teaching the system how the business defines success. This framework provides the acceleration of autonomous agentic execution while maintaining the strict ethical judgment and accountability of human oversight. By integrating advanced logical reasoning, secure factual memory, and active human governance, the AI agent transitions from a reactive chatbot
into a trusted, sovereign enterprise collaborator.